Hello everyone, this is our project about the medium access control protocols and routing protocols. This project was implemented in three parts. The part 1 and part 2 involved one bus which had 2 and 4 nodes connected to it respectively. And part 3 implementation, we had two buses, bus 1, bus 2, which had 2 nodes connected to them, and it was connected by a network of routers R1, R2, R3 and R4, and we were supposed to implement a medium access protocol using collision detection to transfer packets from one node to another node, and also a routing protocol which would take the shortest path for the pair of source and destination nodes. The approach which we have used for our project is a single event thread driven approach, and our simulation is programmed to process different events and generate reports from the updated network statistics using one thread. This is the basic flowchart of our program. We start with initializing the variables. Then we create an event called generate packets for all the nodes. Then we select the next event which is there in our list. We check the event type and process it according to its type. If it is about updating the statistics and the variables, we do so. Otherwise, we create more events that is related to completing the transmission or updating the event list. After the transmission is complete, we remove that process from the event list and check for the simulation time. If the simulation is over, then the process ends. Otherwise, we continue with the next event which is there in our list. Now let's move on to the code. For the part 1 and part 2, we simply implemented it for 4 nodes, and here we have 2 buses. Instead of 2, we had 1 for part 1 and part 2. The buses have information regarding the source nodes, the destination nodes, the generation time of the packet, the transmission time, and the receiving time of the packet, as well as the number of collisions which the packet suffers before successful transmission. So we start by initializing all the parameters. For the sake of simplicity and demo, we have kept the simulation time a little less over here. So we start by the create packet method. In the create packet method, we create a packet with a node ID. The destination node ID, currently we have kept it as empty, and similarly the transmission and receiving time is set to 0 because the packet has just been created. And then we append that packet to our list based on which node created that packet. After creating the packet, we enter the while loop, we update our clock, and we choose the destination node randomly from the list of nodes. And based on what are the combination of source and destination nodes, if the transmission is happening from bus 1 to bus 2, we call this method called routing packets. That means the transmission will require the packets to pass through routers. So here we have generated cost values, which are the cost for each of the links between the routers, and these cost values are uniformly distributed between the range 1 to 10. So here C1 corresponds to the cost of the link between router 1 and router 3, and similarly C2, C3 and C4 for all the pair of routers which are connected. We pass the edge weights and the adjacency matrix to our Dijkstra's algorithm. In Dijkstra's algorithm, we have done the computation for calculating the shortest path for all pair of routers. This returns us the shortest path and shortest least cost values for our generated cost values or the edge weights which we pass. Now let's see how this routing table is updated. So as you can see here, for the first iteration, the cost values generated for corresponding routers are 3, 6, 10 and 10. And after the Dijkstra's algorithm is executed, we get the cost and the path matrix from the method. And this method will be called after every 2 milliseconds, and the routing table will be updated with new cost values, and the Dijkstra's method will be called. So we can see here the updated C1, C2, C3 and C4 values. After routing, we check for the collision case. If there is a collision, then we have written the logic for back off, exponential back off. Otherwise, we are updating the transmission and the receive time for the list, the packet which is on the top of the list, and we add it to our updated simulation list. So when the simulation is over, so we can see the entries of the successful packet transmissions over here. Our simulation list contains 137 packets which were transmitted successfully. So as we can see, the first column represents the source node ID, the second one represents the destination node ID, the third column is for the generation time of the packet, fourth column is for the transmission time of the packet, the fifth column is for the received time of the packet, and the seventh column is for the number of collisions which the packet suffered before it was transmitted successfully. And we have also generated the graphs for the access and the queuing delays over here. So from the graph we can see for the packet number 3 or 4 there is a spike in the access delay for the packet that was transmitted between node 1 and node 3, that is node A and node C. And correspondingly we can also see an increase in queuing delay for this packet sequence number. So this was our project implementation. In the report we have included all implementation details and algorithms. We have also included the simulation results for part 1, part 2, part 3 and the observations. For extra credit, we have included insights based on various scenarios, how the performance parameters will change. We have also mentioned the pros and cons and the challenges. And in conclusion, we would like to say that it was a great learning experience for both of us. Now we know a lot about network traffic and how the internet works. And for that, we would like to thank our professor a lot for her cooperation. Thank you.